Hi everyone. So in this video, we're going to go ahead and talk about Boyle's law, which relates pressure and volume. So let's go ahead and get started. Okay, so Boyle's law tells us that pressure and volume are inversely proportional when temperature or the number of moles is held constant, meaning that if we don't change the temperature and we don't change the amount of stuff we have, as we increase the pressure, the volume will decrease, and vice versa. So as one goes up, the other one has to go down to counteract it. So we can actually graph this trend. If we graph pressure versus volume, we end up with that curved line that steadily goes down. But if we graph pressure versus the inverse of volume, which takes care of the fact that it's inversely proportional, that's how we get a straight line. Now the equation for Boyle's law is P1 times V1 equals P2 times V2. The ones are the initial values, the twos are the final values, and P stands for pressure and V stands for volume. So for a real life example, you have a piston. So these we commonly have in cars and in electric motors. So as you press down on the piston, the volume inside that area decreases. This causes an increase in the pressure, and this is why it becomes more difficult to push the piston down as you continue to press it down further, because the pressure is always increasing. So for a lab example, we have the balloon that was in the syringe. As we push down on the plunger of the syringe, the volume inside that area decreased, therefore the pressure increased. And this caused the balloon to shrink, so that it was taking up less space because it had more pressure pushing down on it. Now, the reverse happened when we pulled back on the plunger. We were increasing the volume, which therefore decreases the pressure inside of that syringe. And that allowed the balloon to expand larger because it wasn't having as much pushing onto it to keep it in that small shape. Okay, so let's go ahead and work through some examples.
Okay, so let's go ahead. And try out some examples. So a sample of oxygen gas has a volume of 150.0 milliliters when its pressure is 0.947 atmospheres. What will the volume of the gas be at a pressure of 0.987 atmospheres if temperature is constant? So if we think about this, the pressure is increasing. So Boyle's law tells us that the volume should be a little bit smaller. So let's go ahead and work through this problem. So we know the equation for Boyle's law is P1 times V1 is equal to P2 times V2. So it's really important for this that you think about the paired values and keep them on the same side of the equation. So one set of paired values is 150 milliliters when its pressure is 0.947 atmospheres. That means the 150 and the 0.947, those have to be either the ones or the twos. And since that's what we're starting off with, we're going to make those the ones. So our initial pressure is 0.947 atmospheres. Our initial volume, our V1, is 150.0 milliliters. Okay, so that means the other value we're given, that is going to be our final pressure, so our P2 is equal to 0.987 atmospheres. And the volume of the second one, V2, that is our unknown, what we are trying to find. So we can go ahead and plug in our values. So we get 0.947 atmospheres times the volume of 150.0 milliliters is equal to our second pressure, 0.987 atmospheres times V2. So to get the V2 by itself, we're going to go ahead and divide both sides by that higher pressure value. And we will see that the units of atmospheres are going to cancel out, which is good. That leaves us with milliliters, which is what we want for our unit for our volume. So V2 is equal to, okay, I'm going to go ahead and plug this into our calculator. So 0.947 times 150 divided by 0.987. Okay, so that gives us a number that's a little bit smaller, so that's what we expected. So let's go ahead and write that one down. So 143.92, but now we want to think about sig figs. So we want to go to the smallest number of sig figs that is in our given. So for our two pressures, they both have 3 sig figs. The leading zero does not count because the leading zeros never count. For the 150, that one has 4 sig figs. The trailing zeros count because there's a decimal point. So we want to round this answer to 3 sig figs, meaning I'm going to cut it off between the 3 and the 9. So 143.9 gets rounded to 144. And then finally, don't forget your unit of milliliters. Okay. So the next problem is actually you try. So I want you to go ahead and try this one by yourself. So when I'm done here, pause the video, try it by yourself, and then come back, and then we'll go over the question, make sure you get the right answer. So make sure you check for your paired values and think about what you're solving for. So go ahead, pause the video, and then we'll be back in a second. Okay, so for our paired values, we have 1.2 liters under a pressure of 2.4 atmospheres. Okay, so our P1 is going to be equal to, this time atmospheres is our unit of pressure. So 2.4 atmospheres. Our volume is now in liters. That is perfectly okay. And then for our P2 and our V2. Well, P2, that one is 3.6 atmospheres. That's one of the other values we're given. And we're being asked to find about the volume again. So that's our unknown. So if we go ahead and set up our equation, P1 V1 is equal to P2 V2. Okay. Now I can plug the values in now, or I can rearrange my equation first. I know I want to get V2 by itself, so I'm going to go ahead and do that. So I get V2 is equal to P1 times V1 divided by P2. And then I'm going to plug in my values. So my P1 is 2.4 atmospheres. My V1 is 1.2 liters. And then my P2 is 3.6 atmospheres. Okay, so if we think about this, my pressure is increasing again, so I would expect my volume to decrease slightly. So if we go ahead and plug this into our calculator, we get 2.4 times 1.2, and then divide by 3.6. So my final volume, 0.8, but we still need to think about sig figs. If we look at each of these values, they all have 2 sig figs. This one right now only has 1 because remember, leading zeros don't count. So we're going to add a 0, okay, which does count because trailing zeros with a decimal point are significant. And then don't forget about your units, which is liters. So that is the second answer. So I hope this helps. If you have any questions, please let me know. Otherwise, I'll see you later. Bye.